Good morning. It's March 27th, and this is your daily brief in science. Here's everything you need to know. The European Space Agency's Gaia Space Telescope has officially been shut down on March 27, 2025, marking the end of a remarkable journey that lasted over a decade. The decision to cease operations was made after Gaia ran out of fuel necessary for its precise positioning, leading to its decommissioning. This shutdown is a standard part of the life cycle of space missions, and Gaia has successfully completed its objectives during its operational period. On its final day, Gaia was moved to a stable retirement orbit around the Sun, approximately 10 million kilometers from Earth, to prevent any unintentional reactivation. Originally intended for a 5-year mission, Gaia exceeded its timeline, with its control team executing a careful strategy to minimize space debris during its retirement. Despite being powered down, the mission continues as scientists analyze the extensive data collected, with future data releases expected to enhance scientific understanding well into the 2030s. Gaia has delivered a wealth of data, mapping nearly 2 billion stars and celestial objects, and providing insights into black holes, exoplanets, and the formation of our solar system. Uwe Lammers, the Gaia mission manager, stated that the mission has significantly changed our understanding of the Milky Way, offering a comprehensive new picture of the galaxy. Notable discoveries from the mission include evidence of past galactic mergers and the identification of new star clusters and exoplanets. Despite its significance, Gaia remains relatively unknown to the general public compared to other space missions. Its legacy will support future missions like ESA's Euclid and Plato, which will rely on its data for further exploration of the universe. The telescope's observations have contributed to over 13,000 studies by astronomers worldwide, significantly advancing the field of astronomy. Researchers at McMaster University in Canada have made a significant breakthrough in the fight against antibiotic resistance with the discovery of a new antibiotic molecule called Lariocidin. This promising compound effectively targets a wide range of bacteria, including those that are drug-resistant, while leaving human cells unharmed. Lariocidin was produced by a soil bacterium named Paenibacillus, which was isolated from soil samples collected from a laboratory technician's garden in Hamilton, Canada. The antibiotic functions by binding to the ribosome and transfer RNA in bacteria, disrupting the reading of genetic codes and leading to the production of toxic peptides that ultimately kill the bacteria. One of Lariocidin's key advantages is its unique mechanism of action that inhibits bacterial protein synthesis, making it difficult for bacteria to develop resistance. This is particularly important given the urgency for new antibiotics, as antimicrobial resistance is linked to approximately 4.5 million deaths annually due to antibiotic-resistant infections. The findings regarding Lariocidin were published in the journal Nature on March 26, 2025, marking a crucial advancement after nearly 3 decades without a new class of antibiotics. The research team, led by Jerry Wright, a professor in biochemistry and biomedical sciences, is now focused on modifying Lariocidin for large-scale production and clinical development. However, the path to commercialization will require significant time and resources, as the bacteria are not currently optimized for pharmaceutical production. Additionally, researchers are exploring a variant of Lariocidin, which resembles a pretzel in shape, as it may offer a more stable candidate for clinical development. Lariocidin's distinct binding site allows it to evade existing bacterial resistance mechanisms, positioning it as a strong contender in the ongoing battle against resistant infections. While the initial discovery is a notable achievement, researchers recognize that the challenging work of developing Lariocidin into a viable drug has only just begun. Overall, Lariocidin represents a critical advancement in antibiotic research, offering hope in addressing the pressing threat of antibiotic resistance. Recent research reveals that toxic dust on Mars presents serious health risks for astronauts during potential missions to the planet. While Martian dust is less sharp than lunar dust, it contains fine particles that can penetrate deep into the lungs and bloodstream, leading to severe pulmonary issues. This dust is composed of hazardous substances including silica, gypsum, perchlorates, and nanophase iron oxides, which can exacerbate health risks for astronauts. A significant challenge is the communication delay of approximately 40 minutes between Mars and Earth, which will hinder remote medical support. This makes it crucial to limit exposure to Martian dust during missions. Experts emphasize the importance of developing comprehensive medical capabilities on Mars, given the difficulties of evacuation back to Earth. Justin Wang, a medical student and co-author of a recent study, warns that fine dust particles can remain in the lungs and enter the bloodstream, compounding existing risks from space radiation. Julia Cartwright, an independent researcher, compares exposure to Martian dust to asbestos, noting that its sharp, angular particles can irritate respiratory tissues. Moreover, exposure to perchlorates in Martian soil may lead to thyroid dysfunction and aplastic anemia, complicating astronaut health further. To mitigate dust exposure, researchers recommend implementing dust filtration systems, cleaning cabins regularly, and utilizing electrostatic repulsion devices during missions. Brian Hynek, a geological sciences professor, stresses that constant dust accumulation will also affect spacecraft and equipment, necessitating regular maintenance. Natalia Zavina-James from the UK Space Agency highlights the ethical implications of astronaut health in Mars exploration, emphasizing the need for thorough consideration before any crewed missions. Despite these risks, Wang believes that with proper preparation, the challenges posed by toxic dust can be managed, making Mars missions feasible. A fascinating new discovery in the world of paleontology has unveiled an ancient wasp, Sirenobethelus charybdis, which possesses a striking structure similar to a Venus flytrap, potentially designed to ensnare its prey. Researchers analyzed 16 female specimens of this wasp, all found in amber from the Kachin region of Myanmar, and noted significant differences in the hindwing vein patterns when compared to modern cuckoo and bethelid wasps. The unique structure of Sirenobethelus charybdis's abdomen is believed to cushion rather than crush its victims, allowing the wasp to lay its eggs on living insects without killing them. This species is classified as a koinobiont parasite, meaning it lays its eggs inside living hosts, such as caterpillars or fly larvae, which then serve as incubators for the developing young. The abdominal morphology of these wasps is particularly noteworthy, as it may have enabled them to restrain live hosts effectively while laying eggs. The discovery of movable abdominal flaps indicates that Sirenobethelus charybdis could grasp its prey when alive, suggesting a passive ambush technique rather than active hunting. Manuel Brazidek from the University of Rennes highlighted the significance of this finding, noting it as a novel evolutionary adaptation for parasitoid insects in immobilizing hosts for reproduction. This discovery not only expands our understanding of insect adaptations throughout history, but also challenges the notion that unique traits are exclusive to modern insects. The closest modern relatives of Sirenobethelus charybdis are parasitoid wasps from the superfamily Chrysidoidea, which includes cuckoo wasps known for laying eggs on or in host insects. The study detailing this remarkable discovery was published on March 26, 2025, in the journal BMC Biology by researchers from Denmark, China, and Brazil. The name of the wasp references Charybdis, a sea monster from Greek mythology, known for creating whirlpools that posed a threat to Odysseus. Researchers at the University of Cambridge have developed an innovative AI tool capable of diagnosing coeliac disease from biopsy images with over 97% accuracy. This advancement significantly enhances the speed of diagnosis, providing results in under a minute. The AI algorithm was trained on more than 4,000 biopsy images sourced from 5 hospitals. It matches the effectiveness of human pathologists, who typically require 5 to 10 minutes to analyze a biopsy sample. Coeliac disease, an autoimmune disorder triggered by gluten, affects approximately 1 in 100 individuals and can lead to severe complications if left undiagnosed. Traditional diagnosis relies on pathologists analyzing biopsy samples from the intestine, a method that can be time-consuming and often inconclusive. Notably, disagreements among pathologists regarding diagnoses occur in over 20% of cases, underscoring the potential for AI to provide consistent and reliable results. Dr. Florian Jäkel emphasized that the AI tool could alleviate waiting lists for patients by delivering rapid results. The research team is collaborating with patient organizations like Coeliac UK to address concerns about AI's explainability and to foster public trust in its medical applications. To commercialize this promising technology, the researchers have established a spin-out company, Lyzeum Limited, with the goal of facilitating faster diagnoses within the NHS. The study received support from organizations including Coeliac UK and Innovate UK, highlighting the need for further investment in digital pathology and effective AI implementation. The algorithm's diagnostic performance, with a sensitivity of over 95% and specificity of almost 98%, suggests its readiness for broader clinical application, particularly in the NHS. Future plans include testing the AI algorithm in larger clinical samples to facilitate its approval for use in the NHS, aiming to revolutionize coeliac disease diagnosis. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.